Alright, AP Scholars, we are looking at the first question from Free Response Question Practice 1. And we're not going to look at the answer in this video, we're just going to look at what is this question asking us to do. And this is a great video to watch if you're stuck, if you're not too sure, if you interpreted the question correctly, and you're just trying to get going with the question, or be at peace with your answer without seeing the answer just yet. So another video will be made for the answer. So here's the deal. We are working inside of a class called the Frog Simulation class. They give us the class here minus some of the implementation details, and then they tell you about some stuff that you're supposed to do. So we're going to be writing the simulate method. That is the purpose of part A. So we're writing a method, and it's going to simulate this frog attempting to hop in a straight line to a goal from the frog's starting position, which is 0. So we'll start at 0, and we're going to see if it gets to a particular distance. There's a maximum number of hops it can make, and at that point, if it hasn't made its distance goal, then it fails. And if it makes its distance goal by that time or before it, then we can say yes, it was successful. So the method returns, yeah, so that's basically what that says. So the frog simulation class, how do you know like how far the frog jumps? Well, that's because it's got this hop distance method. It's sort of basically random. It returns a random number. I don't know exactly. We don't know exactly how it works, but this is how you find out. You call hop distance to see how much in a given hop, how far the frog hopped. So it's an integer, and it can be positive or negative. So it's how far along that straight line it moved. If it moved negative, it jumped away from the goal, which is counterproductive. If it's positive, it moved towards the goal. And each time through this method, you're going to be, calling hop distance to see how far it hopped, and that will help you determine if it was successful or not. Note that the hop distance method is up here, so we can see that it is a with this declaration, and there's some things to keep in mind about its return type, the parameters it takes, and the fact that it's private, and whether that matters or not in this question, since we're working inside of the frog simulation class. There's a couple other details here just to explain what's going on. Just a reminder that the frog, you return true if the frog has reached or passed its goal. The frog hops until one of the conditions becomes true. The frog has reached or passed its goal. So in other words, you don't have to keep on. Like if it jumps the good distance in one hop, you don't have to keep going through all the hops. The frog has reached a negative position. So if it gets into a negative distance, stop. It's false. And the frog has taken the maximum number of hops without reaching the goal. So there's a maximum hops value, and if that is exceeded, it doesn't keep on trying forever. Stops then, and you return false. So here's some examples. So like if we're calling hop distance in a loop, and we got these numbers from hop distance, well, those add up to 24. I didn't actually double check the math there. I'm assuming that's correct. And in this example, the frog simulation class, object that we instantiated, the goal distance is 24, and we have 5 possible hops. So that's why it went all the way through 5, because at this point it wasn't successful. Did another one. It got to 24, so returned true. Here's another example where it generated 6, 7, 6, 6. That already gets to 25, which exceeds the goal, so it doesn't have to do it another time, so it returns true. Here's an example where it got 6, negative 6, and then this frog suddenly took to the skies. It jumped a vast distance and exceeded the thing, so it returned true. Here's a frog though that had some problems. It went 4 and then 2, that's 6, and then -8. Oh no. The total distance became negative, so we gotta quit. Stop. False right away. And this poor frog was just lazy. Just like little dipsy little hops here. Didn't quite. It got to all 5 of its hops because, max hops is 5. So this frog blew it. Got to 18, so returned false. He did not succeed. Yeah. There's a bit more information here just to remind you about, these are the instance variables that you have at your disposal. And these are the methods you have at your disposal. You're running the simulate method. That's the story right there. Bam! Make it happen. I guess in the question, go for it. Hopefully that helps explain what's going on. It's basically a loop that's calling a method to generate random numbers. You're adding the random numbers in, and you just got to watch out for sort of these criteria of when to stop the simulation correctly and how to return true or false. So that's part A. And then in part B, the idea is that you're writing the run simulations method. And in this method, you're going to be performing a number of simulations and basically returning what portion of the simulations were successful as double. So for example, if the parameter passed to run simulations is 400 and 100 of the 400 simulation method calls return true, then our method we're writing in part B will return 0.25 because 25% were successful and we're returning a double. So basically we got I don't know if it's super clear that we're supposed to be calling the simulate method that we just wrote in part A, but the idea is that we're going to be running the simulate method in some kind of loop. We have this parameter for how many times we're supposed to do it. We are going to do a calculation and then return the portion of successful simulations as a double in between 0 and 1. And that's that question. So that's the idea there. And these questions are tricky because, for a lot of reasons, but I think because you're sort of trapped in this class. You got to work with this class, and it's a little bit weird to use somebody else's code. It's also a weird idea. Like, what's this frog deal? Why are we simulating it? What is going on? It's a little bit of a hard to wrap your head around, but hopefully it made sense what we're talking about. And I think that is a pretty good set of hints to give it a try. So go ahead and try it out, and if you're still completely lost in the answers, coming in another video. Okay, thanks everybody. There's also going to be a video for part 2. There'll be both a hint video for question 2, and there'll be a answer video for question 2 as well. Okay, thanks everyone.